Hello class, this is a video tutorial on the intersection of two lines, also known as simultaneous equations. This is the first video in a three-part one. So the first thing you need to understand is when two non-parallel lines are graphed, they will always intersect at a point. So here are two lines, they are not parallel, they will always meet at some point. When we solve, solving simultaneous equations is the process in finding the coordinates of the intersection. So right now we don't know what those values are, but the process which we're going to learn now is how to find the coordinates of that point. The first and perhaps the most straightforward one is graphing them. So the three that we're going to be looking at is solving by graphs, substitution method, and the elimination method. We're going to start with the most straightforward one first. How I will be solving this is using the x and y intercepts of both. So I'm going to start with line 1, then move later on to line 2. Let's begin with line 1. Let's find the x intercept, and we know that the y is equal to 0 at that point. So let's take the equation and we're going to substitute 0 for y. So we have now x plus 2 times 0 minus 4 is equal to 0. We get x minus 4 is equal to 0 because 2 times 0 is 0, which leaves us with x is equal to 4, positive 4. So our first coordinate is 4, 0. Let's move on to the y-intercept now. And we know that the y-intercept, x, is equal to 0. So once again, we're going to substitute 0 for x. So we get 0 plus 2 times, 2y, hasn't changed, minus 4 is equal to 0. Solving for y, we get 2y equals positive 4, moving the 4 over, which leaves us with y is equal to 2. Dividing both sides by 2, which we now have the coordinates 0, 2. Okay, so we'll graph that first one first. 4, 0 is here, and 0, 2 is here. Connecting our points that we've just graphed. That we've just found, sorry, we can graph our line. There we are. And just so that it doesn't take up too much room, I know that we normally would write the coordinates. I'm going to label that one line 1. So we're finished with line 1. Let's move on now to line 2 so we can graph it. Line 2, we're going to be using that equation. Let's once again begin with the x intercept where the y is equal to 0. So we're going to solve for x by substituting y. So we get 0 is equal to 2x minus 3. 2x minus 3. Solving for x, we get negative 2x is equal to negative 3, moving the 2x over. And then we're going to divide both by negative 2. So x equals negative 3 divided by negative 2. X gives me a positive 1.5. So the first coordinate is 1.5, 0. The next coordinate we need is the y-intercept. And at this point, x is equal to 0. Once again, we'll substitute x for 0 here. So we get y is equal to 2 times 0 minus 3. We get y is equal to 0 minus 3. We get y is equal to negative 3. So our coordinate now is 0, negative 3. Using these 2 points, we'll begin with this one, 0, negative 3, and 1.5, 0. So let's get this as exact as we possibly can. That's about 1 centimeter, so there it is there. Connecting these 2 points, there we are, and that there is our line 2. That's line 2. And we can see from our graph that it is actually intersecting rather at that point there. It's intersecting at that point, that is 2, 1. So the intersection of these 2 points is 2, 1. Okay, let's move on to another example. I'm going to work a lot faster for this one now. So here we go. Let's begin. We have line 1 and line 2. So let's find line 1. Let's find the x-intercept first of y is equal to 0. So we're going to have now 3x minus 2 times 0 equals 19. We get 3x is equal to 19, which gives me x is equal to, that's about 6.6 and 1/9. Let me check here. 19 divided by 3 as a decimal is 6.3 recurring. This gives me 6.3 recurring. So the first coordinate I need is 6.30. Let's now move on and find the y-intercept, where x is equal to 0. Substituting 0 for x in our first coordinate, first equation, we get 3 times 0 minus 2y equals 19. This will give us negative 2y equals 19. Dividing both sides by 2, we get y equals 19 divided by negative 2. Let's try that there. 19 divided by negative 2 gives me negative 9.5. Negative 9.5. And our next coordinate now is 0, negative 9.5. Let's graph these 2 points first. Let's start with this one here, 9.5. So that's negative 9. There's negative 9.5, approximately there. And 6.3, that's a little tricky. That's 6.5 there. Okay, 6.25, so it's slightly over. So let's just put it right there. Connecting these 2 points. There we are. That's line 1. Let's move on now to line 2. Line 2. We'll find the x-intercept first, where y is equal to 0. So let's take a look. We have 4, whoops, that's 4y. It's a little tricky. So 4 times 0 plus x plus 3 is equal to 0. That gives me x plus 3 is equal to 0 because that goes away, which gives me x is equal to negative 3. So our first coordinate is actually negative 3, 0. That's not good because we need more points there, but that's okay. We'll figure this out. Let's find the y-intercept now, where x is equal to 0. So here we go. We have now 4y plus 0, because we're substituting into the next line, plus 3 is equal to 0. We now have 4y plus 3 is equal to 0, which gives me 4y equals negative 3. Y equals negative 3 divided by 4. That is 0.75 as a negative. So let's extend this line slightly. Oh, it's going to get a little cramped in here, but that's okay. All for the sake of getting the correct answer. 1, 2, 3. It's negative 1, negative 2, negative 3. So the points that we need are negative 3, 0 and negative 0.75. So there's halfway between is about there. So using these 2 points, we'll connect the points like that. There's our line 2. And from the looks of it, it looks like it's intercepting at 5, negative 2. Oh, it's a bit off from the graph, which is a good segue. So let's test 5, negative 2. Let's see whether or not this works. Okay, so now this is the guess and check portion of this segment. So this is the guess and check. So let's test 5, negative 2 in both of our lines here. So I'm just going to copy that out. We have 3x minus 2y equals 19 and 4y plus x plus 3 is equal to 0. So let's test in line 1. So line 1. So if we substitute the x here and the y here, we should get 19. So here we go. 3x minus 2y equals 19. Substituting 5 for x, we get 3 times 5 minus 2 times minus 2 equals 19. Will this equal 19? So that gives me 15. Negative 2 times negative 2 is plus 4. From the looks of it, 19 does equal 19. So that works. Now let's test it in our line 2. So 4y plus x plus 3 should equal to 0. So let's substitute these values in. 4 times y, which is negative 2, plus 5, which is the x value here, plus 3 is equal to 0, which is from the original equation. We get -8 plus 5 plus 3 is equal to 0. -8 plus 8 is equal to 0. 0 does equal 0. So when we substitute this point into both equations, they both hold true. So therefore the intersection of these two lines, of line 1 and line 2, is indeed 5, -2. It's a long process, but this is how we calculate the intersection of 2 points by a graphical method.